Welcome to episode 5 of the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. We're going to talk philosophy of welding, welding codes, welding defects, and topics like that. My name is Garry Pace. I'm a welding engineer and a CWI. And in this episode, I have a conversation with Jeffrey Jones, who is a welding coordinator by day for a utility in the Midwest and teaches welding at night at a community college in the KC area. We're going to take a little break from our deep dive into AWS D1.1. So in this episode, I have a different guest, Jeffrey Jones, who I just mentioned, and we're going to have a discussion about welder training, general philosophy of that, as well as an overview of the CWI exam and some overall thoughts on the CWI exam and maybe some strategies or directions a person can go in regards to studying for the CWI exam. All right, you're on an episode of the Welding Codex with Garry Pace and Jeffrey Jones. My name is Garry Pace, and I'm a welding engineer by trade. I teach high school welding here in Houston. I crossed paths with Mr. Jones here years ago when I was working up in Kansas City. He was the AWS section president for the Kansas City section, and he's trains welders is one of his, I guess, hobbies, jobs, vocations. Anyways, Jeff, would you like to introduce yourself and tell us a little something about yourself?
Sure. My name is Jeffrey Jones, obviously, and I have been in welding-related fields since I was probably 17. That's probably another episode why I started so young, but we started in a high school program my senior year in high school. Got out of that, worked 4 years at a machine shop as the only welder in the shop, welding a lot of GTAW, TIG work. Grew up through that, did 4 years with them, learned a lot about different materials, all kinds of exotics. Then went into, I think it was after I turned 21, 22, I tested into the pipe fitters and went for pipe fitters and did that, traveled from Philadelphia to Alaska, Chicago, Detroit. Did that for, I don't know, up to 10 years traveling, and then decided, maybe it would be wise to get my CWI. 2006 time frame, I got my CWI, and part of the Alaska stint, went up there, worked on the pipeline, just went all over. So finally made my way back to Kansas City. I was working on a power plant and as a pipe fitter, and ended up getting on with that power company as their welding coordinator, trainer. And I think that was back in 2011 when I started with them. And that job entails all the welder training. It's an apprenticeship program, as well as all the welder qualifications, welding procedures, PQRs, all of the documentation involved in that, as well as all of the normal quality control and quality, QC manuals, R-stamp manuals. So we have boilers, so we use the R-stamp program, repair stamp program with the MBIC. And then about 6 years ago, I'd started with, at night, working 4 nights a week for a local community college. And I've been doing that again for 6 years. So I've been in this industry, I guess now almost over 20 years, and it's pretty crazy to think that it's only been 20 years, or it's been 20 years. That's a little bit about me, kind of a quick rundown of my history.
All right, now that we've got the introductions out of the way, Jeff, I'm going to dive into this and ask a few questions, get a conversation going, and see where this podcast ends up. What are the welding processes most used in your industry in power? Are you guys still pretty stick heavy, or have you moved beyond stick into other processes that maybe aren't as archaic?
We're pretty stick heavy with our repair or our maintenance welders. We do have a lot of contractors that come in. We had a reheat line that they came and put in. It was some heavy wall chrome. They put a TIG stringer and they flux cored it out. So our contractors are a little more advanced than we are. We don't find that we need or rely on those MIG processes for that speed because we don't need it. Our maintenance welders will do one-offs more than they'll, put a whole line in. So Repair welding is a lot more stick heavy, TIG heavy. If they're in the shop, they'll make some stuff, but for the most part, it is all stick welding.
So for the consumables you use there, I assume that you use some 60-10, 70-10, and then your general varieties of low hydrogen, the 70-18s, 80-18s, 90-18s in your repair activities, correct?
Correct. We don't use much 70-10. We just try to stick with the 60-10, and that's mostly on water systems, stuff that's not critical systems. The only time we'll use the 60-10. If we're putting a stringer in on those other critical systems, that'll be a TIG or a GTAW stringer.
Okay, so you mentioned that had an apprenticeship program. So what skills outside of, let's say, just deposition of weld metal do you look for when bringing somebody into the welding family, the welding trade? Is there, reading of blueprints, tape measures? What is there that they need to bring with them if they're coming into our family?
So that's a good question. Our apprenticeship program is a no skill, no requirement program. That it's a bid process internally that they get these with. But yes, it's always great to have those blueprint reading skills or just life skills in general, as far as some type of construction that really help out with even learning this, some kind of mechanical background of some sort.
I mentioned since we last crossed paths, came down here to Texas and now teach high school welding, and I try and feed my students into trades when we're pretty stick heavy. But I also make sure in tape measure math, try and get them a little bit of vocabulary in regards to metallurgy, understanding what a WPS is and a PQR. And I think a lot of that and I come at it from an engineering standpoint. I wasn't a welder per se. I was a boiler operator in the Navy and then have dealt with welders for the last 30 years off and on. So I guess I come at it from a different direction, but I understand that, you got to be able to read blueprints, weld symbols, have some vocabulary, give you a leg up.
That gives you a leg up on those items when you want to become into supervision. As a general grunt welder, a lot of times those skills are helpful, and it depends 100% on the job, where you're at, what you're doing. Is it large construction like a power plant, or is it small construction like a school? A school, you're more likely to be working directly with the foreman on helping with those blueprints. But when I was in the power plant industry or the refining industry, we typically, a drawing or a schematic or a blueprint was few and far between. I know our maintenance welders, they're lucky if they get a hand sketch drawing. So it goes the full gambit there on what you need and how you need it, but it's always great in the beginning to have a good foundation. At least you've seen one.
What was your biggest challenge when you went from making the welds to starting to train people to weld? Walk us through some of the learning curve that some things that you had to overcome to be an effective instructor.
So I'd say the learning curve is still on its curve with me. As far as a guy in a booth welding, 100%, we can get that taken care of, no problem. It's the classroom work that I still struggle with, because I guess being a self-learner on a lot of that stuff, it always intrigued me, so I was always reading something, trying to keep up with it. So getting these kids into the classroom and standing and lecturing to them, I usually have their attention, but if you draw it out a long time, you usually lose their attention. So some of this online learning works good for that, but it always is helpful to bring it home with a little bit of lecture and a little bit of back and forth with them. I think there's a good combination there. So I guess my philosophy would be there's a good combination between the online learning and the lecture in a classroom, as opposed to, I'd say it's about I'm about a 90% in the shop. Welding is the only way you're going to learn it, and then try to pick up those small details of what I feel like is real important in the classroom.
My setup in the way I teach in the A-Leaf ISD Career Center is I'm usually 2 days in the classroom and then 3 days in the shop. So I'm about 60-40, but it's the way my class periods fall out. I try and have them in the classroom, and then we do, like you say, the online stuff. And part of it, I think, with the kids coming up is they don't have a hell of a long attention span. So, like, if I give them a quiz from my online material, I give them about 10 or 12 questions, and then we're done.
Yeah.
And I think in lecturing too, if somebody's listening to this and thinking of getting into being a welding instructor, if I'm lecturing, I try and tie it to a story.
Yeah.
Okay, I was on this project this one time and this happened, or I ran across this and this happened, and try and give them something that it ties to. And I think I've had kids come back to me and, oh, that's like when you were telling us, and they'll tell you something. It's like, oh man, you guys were listening. So
Yeah.
I'm coming at it from a different direction. So for me, a lot of the challenge was, how do I not overload these guys too?
Right.
Start talking crazy metallurgy, welding engineer zone of the universe and just bury them.
Yeah, when you start seeing that deer in the headlight look on a lot of what you're talking about, to dial it back a little bit. So, but it is hard because some of the information is very critical, and they might need to know it. But when you're just talking over their head, it's not doing much good without a background on it. So.
No, and I think one of my philosophies is I tell my students that I teach it like it's a language almost, like you're going into Spanish class or German class. There's so much vocabulary involved in the welding trade. Schedule 80, austenitic stainless steel, creep resistance enhanced ferritics, low hydrogen. I mean, there's just hydrogen bakeout. There's just so much information, and you can be a native English speaker. You and I could have a conversation about welding in front of my mom or your mom in English, and they would be like, what just happened?
It wouldn't even have to be our mom. I have a boss right now that has been in training, and he's been a technician, electrician past, right? And so now he's my training manager, and me and you could have a conversation about welding, and it's Greek to him. And he'll tell me that too, because I'll write him an email, or I'll send him an email that I've been conversing with a welding engineer or a R-stamp engineer, boiler engineer, whichever engineer it is, about what's going on, what they need to do with their welding. And he'll read that email and he's like, that's great, but I have no idea what you're talking about. And so it's not just people that are our family members. It's people that are in our industry as well that are still a nice ignorant. They're just ignorant of what the terminology is, like you said.
Yeah, and I kind of try and hit my students with a lot of it and hope that, I hit them with 10 words and they get 5, and then they'll figure a bunch of it out later. So kind of some teaching philosophies there if you're listening to this and maybe you're heading into training welders or it's something you wanted to do.
Yeah. Yeah, in that vocabulary and talking in trades or in tongues, like we're speaking Greek to most people. That's how I have another instructor that works with me at night, and when we work together and when we work with the students, it is that way. We try to speak to them like they're on a job site, and if they don't understand, we try to help them, but at least they get that banter, they get that feedback immediately on whether they understand it or not. And like you said, if you feed them 10 and they get 5 out of it, you're doing a good job.
Well, in the district I teach in is a majority of my students are bilingual, English, Spanish. But I tell them my example is the word nosotros, which is the Spanish word for us. And I said, when I was learning what Spanish I know, it took me 58 times of hearing that word nosotros to understand, oh, us. And I said, you guys are going to be the same with a lot of this vocabulary as you head into the trades. Start talking about TIG or tungsten electrodes, or, just there's a whole variety of just different terms and thoughts and concepts that, is very specific to our trade that you're going to have to get a handle on. So, where do you see welding training going in the next 10 years?
Was that welder training?
Yeah, where do you see welder training going in the next 10 years?
So, being from the old school and the old stickhead, I hate to see that being any less emphasized, but I believe it's going to be. I think the robotics technology is definitely becoming much more user friendly for us old, say, gearheads or whatever you want to call us, that aren't technologically advanced in programming. I think those machines are coming a long ways, and they're not necessarily going to take our place, but they are going to make our jobs less repetitive for ourselves, more repetitive for them. So those jobs that become more repetitive, no matter what they are, they're going to become automated. They still need the welding craft, so it's like you can't teach automation and put a non-welder on an automated machine and then try to get them to understand how welding works. You have to still train them in the manual side of welding, which still takes the same amount of time. And then hopefully, if they're technologically advanced enough that they can do some of the automation, then you train them on the automation. Our community college is investing quite a bit of money into robotics and sending us instructors to Lincoln Electric to do their robotics courses, robotics training, and then we then in turn implement it into ours. In the next 10 years, I could see it that we could have in our maintenance shops some sort of robotics. We already have, the turntables, but those have been in the shops forever. But I'm talking about a robotic arm that welds. I could see that happening in the next 10 years, possibly. Maybe not in the coal industry, but in a maintenance shop scenario, I could see that happening. So our training does need to lean towards that. It's just like any other, what is a WPS, what is a PQR? They need to at least have some idea on how to program a robot. And what that looks like is going to be different for every school, I'm sure. But whether it's an urban school or a city school. But in the next 10 years, unfortunately, I believe that robotics is going to be a huge part of it.
Yeah, I'm with you in regards to, I teach stick. We do a lot of 60-10, pad of beads, flat, horizontal, uphill. Just get it perfect, and then when you got the 60-10 down, we'll switch over to 70-18, and we can start the whole process all over again.
Yeah.
And then I'm also of the frame of mind that once you kind of got stick figured out, it's not going to take you very long to figure out the flux core or the MIG welding or the gas metal arc welding.
Yeah, I agree with that. And that's what I was going to say. I think that thought crossed my mind earlier when you were talking about that. How do you go about training a welder? I think you have to start with the basics, and the basics is stick. Once you get the idea and know how to weld stick, the other processes are going to come fairly easy.
I agree. Once you have stick down, the other processes are going to come together for whoever's learning the welding processes. Stick is definitely a good precursor to learning the other welding processes. That being said, I haven't started training any TIG weld yet. I think with them, it's you got to get them going. First, you got to get stick, and then being able to, understanding the puddle and how to wash things in, and understanding some of that vocabulary before you can, move them on to something else.
Yeah. TIG is the GTAW process is by far the hardest one to teach for a beginning welder. So the way our school works, our college, is at night we have to teach every semester class X. Well, if we have students that start in January, they get started on GMAW and GTAW. They don't even get stick until they come back in the fall, and I think it does them a little bit of an injustice because I believe that you're starting, MIG, obviously we know we can do that pretty easy, but I think it gives them a false sense of security on how they're welding with MIG. So when we move to TIG, it's like just mind blowing. And, dealing with what we're dealing with right now, this COVID-19, we had kids that were coming off of spring break that were getting ready to jump right into GTAW, and here they're going to miss this whole last 4 weeks or 8 weeks of the semester. And they're trying to get us, and it's fine. We're trying our best, but there's no way we can do it. We're trying to teach them this GTAW process through an online program, and it just doesn't work that way. It is a hands-on process, and so hopefully we'll be able to get them back here in the fall and go over it with them. But
I started learning gas tungsten arc welding. I learned how to gas weld first,
yeah,
like the old oxyacetylene. And the guy that taught me was an old Boilermaker. And then his philosophy was you didn't even get filler metal until you were just absolutely great with running a puddle with the oxyacetylene. And then he gave you filler metal. And then you got to do that. And then when you were done with that, the next semester you came back and you did 60-10 and 70-18. So for me, when I go to TIG welding, it's like gas welding, the old oxy fuel welding in your dad's garage or your grandpa's garage or whatever back in the 1980s. You got that hand motion instead of your puddle being caused by consumption of acetylene, and this way you're just getting a non-consumable electrode, run a little electricity through it, and that's how you're getting your puddle.
But we do teach our students in their what's supposed to be their first semester, that fall semester, they do get taught oxy fuel welding. So that does help them prepare for the second semester, which is supposed to be GMAW and GTAW. So the way we start them, anyway, that's something for our dean to help us work through to make sure we can give them what they need. But our program does do the oxy fuel welding.
Yeah, and I was going to agree with you too that the gas metal arc welding does give a false sense of security on, oh yeah, I'm running this stuff great, man. We're just pouring the coals to it. Everything's beautiful. And then you get them over to stick welding and it's like, well, what's this whip and pause with the 60-10? This is fire and brimstone and something out of the Old Testament here.
Yeah, absolutely. And then getting them to stop the whip and pause when they go to 70-18 takes a few days, and it's just I guess just one of those things. That's why we tell them that the only way to learn how to weld is under a hood.
I keep a box of 70-24 around, so let's say a kid has a really messed up test plate, I'll just run a pass of that over there to kind of give him a clean canvas. And we let the kids run, some 70-24 about halfway through the semester just to see why are we welding like that with this stuff? Do you see how great that bead looks? And it's like, I can't get you a job with this stuff. Nobody's going to pay you for this stuff. You got to be able to weld with the 60-10 and the 70-18 or a couple of other processes. I know it looks fantastic and it looks just like glass, but we need to put it into perspective here.
Yeah, definitely.
So do you start them with 60-10 or do you go 60-13, or what's your philosophy on the progression through the stick materials?
At the school, we don't have much leeway. It's 60-10 or 70-18. We don't have any other rod at the college because I don't run the program. I'm just a night instructor.
Right.
But I think 60-10 is a good one to start with no matter what. It seems to strike really good, and that helps them start that confidence and build that confidence. But yeah, we definitely start with 60-10, and they get fairly proficient at it. I'm not as picky with it because it's just a messy rod. As long as I can see they're stacking dimes, so to speak, and not stacking arrowheads, we're probably pretty good.
Yeah, that's getting them to get that progression with the whip and pause, and like you say, not getting arrowheads, or in the uphill position, getting them to understand, hey, you got to get moving, dude. We're not here to deposit weld metal. You're just putting in one pass, so then whatever follows up on the 70-18 is going to grab onto that. So you need to get moving, and they'll have it dripping out and looking like stalactites. And I know you know what I'm talking about here.
Oh yeah.
Getting them to understand, hey, you got to get moving here. One of the other things that I've had trouble communicating was the need when you switch from 60-10, like we'll run 1/8 60-10, and then go to 1/8 7018 and they'll want to run it on the same amperage.
Yeah.
And telling them, no, dude, you got to crank it up on that 7018. You got to run the 7018 way hotter because, 6010 is a coat hanger with wood chips and paper on it. That flux is burning.
Yes.
The other one is, a mineral, basically dirt. So you got to melt the dirt with the 7018. So, you got to run that a lot hotter. You can't have it. You're going to have some ropey looking, humped up, nasty looking welds if you try and run it at the same amperage. So.
Yeah. When I go in the trade welding pipe as a pipe fitter, if it wasn't usually if it was under 8-inch pipe, we would always just run 6010, 1/8 and 7018 3/32, and I would never have to change my machine more than 5 to 10, amperage. And so I try to pass that along, that if you weld with this rod first and this rod second, you don't really have to change your machine much. But everyone, there's always those students that will grab that 1/8 and never change their amperage. So
yeah, that throws people for a loop because we have a limited number of rod ovens. So sometimes we'll run 7018 332 and sometimes it's 7018 1/8, and they're like, hey, this is running wrong. What's wrong with this? It's like, dude, you gotta either crank up the amperage or turn that stuff down. So
yeah.
I do try and pass that information along when I change material diameters.
Right.
Let them know, hey, we need to make an adjustment here.
I do notice that students like to get stuck on that number. I want that number that I need to run this rod at. And I try to stay away from that. I give them range, or I give them a starting point, and I tell them that you need to adjust, but this is where you need to start. But they try to get stuck on that one number, that I run this rod at this amperage no matter what. And, in the shop, you're welding with a stinger that's 6 foot long and it's double-aught cable, right? And you get out in the field and you're running 200 foot of 1/aught cable. So it's going to run different. And so I try not to get them stuck on one amperage and one number on that. And that goes for all processes.
Yeah, so it's important to give them that base knowledge that, hey, it's not a number.
Yeah.
It's like ordering a pizza. There's kind of a variation in there. Do you want extra pepperoni? Do you want extra cheese? I'm giving you the base here, but you got a little leeway here.
Right.
Some direction to go. All right. So if you had a magic wand and could have trainees come into either your program at your work or your night job with a couple of skills, what would they be?
Oh, shoot. A couple of skills. To finish the program, I definitely would like to see a little bit of tape measure, like you said, knowing how to read a tape measure, and a little bit of math, basic math. You don't need to be a geometry specialist or a algebra specialist. You just need to know measurements. And some people, to me, that's different. Some people get that confused with each other. I believe that a tape measure is its own math, and I can show them that math very easily. So definitely a tape measure. I believe you need to read that, and just come with a good attitude and ready to learn, and don't expect it just to come freely. You're going to have to bust your ass. So a good work ethic would definitely be right at the top of the list.
We've probably beat that dead horse a little bit. Let's talk about taking the CWI exam. You're a CWI, I'm a CWI. I came at it from a different direction than you did. I was engineering guy, worked for one of the guys that Richard Campbell, he gives the AWS seminars. I was out at the Hanford site. He made sure that we were all going to be CWIs. So he kind of walked us through it, but most of us were welding engineers that took the exam. So it wasn't, super difficult, I guess, from my point of view, but that's just having swam in that pool for 15 years before I took it. Coming out of the trades, coming from the, you came into the CWI on a different vector. What advice, direction, thoughts, what do you say to those people that are looking to take the CWI exam?
Wow. That's a tough one. I came at it from a perspective that I knew I didn't want to weld the rest of my life, or I knew I wasn't going to be able to weld the rest of my life. So I felt like I needed to start moving towards something that maybe not be quite as physical. So from that point, I really just got the books and I studied. That's what I meant by self-study. I'm not a big reader. I don't read books every day, but when it come to this technical stuff and knowing what it was and how it was, I definitely was able to dive in, because you tell me that weld is bad, you need to tell me why. And if you can't tell me why, then I'll go look it up myself and I'll tell you why. So that really helped me do that, just having access to the code books and being able to look up that stuff myself in the trades. As far as coming from the trades right into it, I think it's a pretty good transition. I think you understand why and what you're inspecting a lot better maybe than the engineering type. But when you throw the CWI exam into it, it's learning all that book work that you guys already have a handle on. And so that's a disadvantage for us. You got to be willing to put the time in with the books to pass the CWI exam. I don't necessarily think it makes one or the other a better CWI, but I think that coming from the trade, it was a harder row to hoe for me. I took the test with the pipe fitters local in Tulsa, Oklahoma, and we started on a Saturday, I believe 8 o'clock in the morning, Saturday morning. I had to take a week off of work for it. We started Saturday morning, 8 o'clock. We went 10 hours Saturday, 10 hours Sunday, 10 hours Monday. And this is in seminar at our training center in Tulsa with the pipe fitters. And then Tuesday, I think we busted it back to 8 hours, and we did 8 hours the rest of the week. And on top of those 10-hour days and 8-hour days, it was highly recommended you go home and you lock yourself in your room or a closet or a desk with headphones in where nobody can bother you, and you spend whatever time it takes to go back over the material that you had went over that day. And so that was the way I spent that whole week and then tested. So it was a pretty stressful week, but it was well worth it, obviously, where I am today. So
Yeah, I came from the other side. So for me, there's three parts of the CWI exam for those of you that don't know. You've got the part A, which is general knowledge, which, like you say, coming from the engineering side, we've pretty much got that one covered. Okay, what's the 70 and 70-18 or all, a lot of this information that is in there. And I was working at Hanford, so I was doing the inspecting a lot of welds, and I was a VT. So part B wasn't too bad. But then you get into the code. The code is where a lot of guys get tripped up because you're not used to reading it and dealing with it and depending on which code you use. I took it in D1.1. We were working with it quite a bit, and if you're used to doing it, it's not too bad. I think I passed it on the first time, but I've helped a couple of friends of mine. I worked with a guy out at a foundry in Tacoma, Washington, and he was an inspector and had been an inspector for years. And he's like, yeah, I always wanted to take the CWI exam and I've just never, and I was like, dude, take the damn thing. You can pass it. You've got the body of knowledge. And I kind of gave him a shot in the arm, and we got him a code book, D11, and he read that thing cover to cover. He ended up passing it. Anyways, that friend of mine, he really studied the code section of it, and he had a pretty solid body of knowledge in regards to welding. But getting AWS D1.1 dialed in was kind of understanding, okay, which parts of the code am I jumping back and forth into, what's going on here, shall, may, should, all that kind of stuff was a little different for him. Like you're saying, if you're going to take the test, you just got to read, and you got to read a lot. And if you haven't been reading about the codes, you want to brush up, it doesn't hurt to start 6, 8, 10 months or a year early. This isn't a test that you can generally as a welder just dive into. You might have the knowledge, but being able to answer questions and dive into that deep end of the pool. And I think that's why there's such a failure rate on it too.
Yeah, I agree. I know just because we have those CWI exams here in Kansas City with the local AWS section, and I hear a lot of those guys that go through it, there are a lot of the trades. I know because they hold it at the Ironworkers Training Center. There's a lot of them that are ironworkers, a lot of Boilermakers, And a lot of these guys are taking it, and they're all failing on the part B, so like the hands-on part. And I've never really understood that, but if you get some of these tools and equipment, you may have never seen it before, and they don't really give you a list of that equipment that you're going to be using. And if you've never measured a fillet weld before, it can be difficult. As simple of a weld as it is, it can be difficult to measure it if you don't know what tool you're using or have never used it. So I found with a lot of the trade guys, some of that part's a little bit more difficult.
Well, there's a couple of companies that you'll see that just offer the part B. Come in and we'll give you 40 or 80 hours on part B.
Yeah.
We're gonna hit you really hard with the part B. Well, and with fillet welds, you're talking, there's the convex side and you've got the concave side, and it can be tricky. And then the wording, reading comprehension as an inspector is super important.
Huge. Yeah.
If you don't have that and you can't read the fine print in regards to, okay, this many pores and this many cracks, and then it's added up unless, if, when, but.
Yeah. It's definitely something you have to practice at a little bit, and I could definitely see why someone would need a 40-hour course on it. I didn't require that because I'm kind of I guess you could call it tech guy, so I like those neat little tools, and I was always fascinated by them, so it wasn't that difficult for me.
And I was a machinist mate in the Navy, so, using micrometers and some of that stuff was played into my ability to pass the exam. But like I said, I've had 2 or 3 people in the last 20 some years that I have helped with the CWI exam. And my brother and he took it after I did. And we called it the box of evil, but it was just this box of material and study material. See a couple of copies of D11 in there and other stuff. I was going to say, there's a lot of material out there that people don't realize is really out there. It's got the same information. If you're saving up money to buy the AWS study guides and whatnot, you get your average high school welding textbook and you read through that thing cover to cover. That thing is going to cover you part A and a bunch of part B.
I totally agree.
Another one that has got a lot of information, and this is, I throw this out there quite a bit, is the U.S. Navy has been training people how to weld for 80, 100 years. So they've got these welder training programs that are all non-copyrighted, open source, open whatever. And if you know where to find them on the internet, it's a CB course, construction battalion, but steel workers, if you type in steel worker correspondence course, it'll take you to that. And it's got, hundreds of pages and it talks about weld defects. It talks about the welding processes, because you're taking somebody from ground zero, graduated from high school in Miles City, Montana, or wherever, Arkansas, or, and you're turning this person into a welder. So they've got these, taking them from ground zero to where they can make a proficient weld on a battleship, or not that there's any battleships left, but a warship. Right. Well, anything you think we left out, or have we covered it all, or?
Oh, heck, I don't know. I guess we can save it for the next one.
Yeah.
If we forgot anything.
Yeah, I think we covered a lot of ground here in regards to, like I say, covered training welders and maybe some, insight into, if you're headed into the CWI world or you're a welder and you want to head into the CWI world, some things you need to take into consideration or look at, or, rehashing with the CWI is, don't underestimate that damn test. Do not underestimate that test. Start a year out, read things, read articles on the internet, go to, Lincoln's websites, read about filler materials, read. That's my theory on passing the test. You need to really soak up a lot of knowledge a long way in advance. You can't just cram for the CWI. All right, well, let's wrap this up then, Jeffrey. I appreciate you coming on. I appreciate you being a guest. We'll have to have you come on here again sometime.
Yeah, I'll be happy to. I appreciate the opportunity to come on here and talk your leg off. Hopefully it was good information, and I got some other ideas I might throw your way for the next couple.
All right. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal, throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry, Pace, Welding, ASME, or AWS, D1.1, there's a bunch of videos on there. Check those out too if you're interested.